To start the experiment, we need to weigh out our starting materials that are not in excess. In the round bottom flask, we already have the ethanol, a reagent, in excess, and its catalyst, concentrated sulfuric acid. 4-amino-benzoic acid is the reagent that isn't in excess, so it needs to be accurately weighed if we're going to perform a percentage yield. To start, we weigh the small container that contains the 4-amino-benzoic acid. We then empty this container into our reaction vessel and weigh the empty container. The difference in the weights leads us to the mass of 4-amino-benzoic acid we actually have in the reaction. The method of reflux is often employed in organic chemical reactions. Inorganic chemistry is a faster rate of reaction than organic chemistry. In general terms, reflux allows us to heat up volatile materials or reactions that produce volatile products in a situation that doesn't allow any volatile materials to leave the reaction vessel. The vertical condenser simply delivers the condensed vapor back into the reaction mixture. We're using a heating mantle here rather than a Bunsen flame. Volatile materials used in organic chemistry tend to be inflammable. The heating mantle is also fitted with a magnetic stirrer, which we're not using in this situation. A heating mantle also can be connected to a computer to heat up a reaction mixture at different temperatures over differing periods. The heating mantle also allows a more controlled heating to take place. The position where the condensation takes place in the condenser should not be any higher than 2/3 the way up the column. Otherwise you're likely to lose vapor out of the column. You can get condensers which are longer than the ones that we have employed here if high temperature reflux is required. If you notice, there is an additional piece to a normal heating mantle that surrounds the lower half of the round bottom flask to make sure heat is delivered more evenly. You should note that many diagrams for reflux in textbooks tend to be wrong. There should only be one clamp engaged in the apparatus, and that secures the neck of the reaction vessel. The condenser merely sits into the top of the reaction vessel. And this makes it easier to remove once the reaction is complete. You've only got one clamp to remove the reaction vessel from the heating mantle. In the laboratory that we're using here, we have a chilled water supply permanently connected up to a condenser, so we don't have to worry about using taps that may cause flooding. Once the reflux has been completed, and remember, the time for reflux has been calculated by numerous previous experiments, we can then proceed to let the reaction mixture cool down, ready for the next step.